In the first three steps of the problem, we have determined what is Y bus and what is the bus diagram. So coming to the Y bus, which we had in the morning, I am writing down in polar format. I think somebody do have the data. Was it so? 24.23 at an angle of minus 76. Is the number? Was it the problem, guys? It is the same problem which we have done in the morning. This was the data which we have obtained in the morning and then in our last class. This was on Y bus. The second data set which we have tried is on bus data, where we had three buses. We had first bus as slack bus, second bus was PQ bus, third bus was PV bus. And we remember that can somebody remember the values? I think this is the data which has been given for us, isn't it, guys? Am I true? Is it clear up to this one?
Yes, sir.
After step number 1 and 2, what we have done? We have gone with step number 3. We have assumed unknown voltages as 0 and unknown angles as 0 and unknown voltage magnitudes as 1 per unit. So I have mentioned V2 mod, which is unknown for me, as 1 per unit, and delta 2 and delta 3 as 0. Now, we will move on to our first method, which is Newton-Raphson polar method. We will go to our Newton-Raphson polar method. And the Newton-Raphson polar method, what we are supposed to do? We are supposed to compute. First of all, let's go with the reactive part. What are the unknown reactive parts? See, the first one is a slack bus. These two parameters can be obtained only at the end of the solution. So what you are supposed to determine now? This is delta 2, delta 3, two angles, one voltage magnitude. The other one is a reactive. The other one is a reactive. Now I am starting with the reactive part, which is unknown for me. This is Q3. So first of all, I will calculate Q3. What is Q3 formula? We know the formula is minus sigma j is equal to 1 to n. This was the formula. So where j varied from 1 to 3, I was specifically this value 3. So here I'll write j is equal to 1, 2, 3, whereas I is fixed 3. So I will write it down now. V3, this is Vj will vary. So this was the formula where j is equal to 1 to 3. Now I will write it down. I have all the data which is required in these two tables. So that's why writing these two tables is important for us. So once you do have these two tables, you can easily write this data here. In V3, 1.04. V1 is 1.04. Y13, see this is Y13, magnitude only I need 4.13. I know angle is 104 plus 0 minus 0 because the angles are all 0. V3 1.04, V2 is 1, 2, 3, it is 12.13 again. The last one is 1.04 into 1.04. Y33 is 24.23 sin of minus 76 plus 0 minus 0. Can somebody tell me what is the value of this one? Somebody, those who do have the calcium. Can somebody try this one? Give me an option.
.28, sir.
Sure, 0.28. Any other
So
answer?
0.8.
0.28.
28.
Any other answers from anyone of you guys? So I take this one as granted. So what is the value button?
0.28, sir.
Minus, because minus is there outside.
No, sir. With minus, I have just
Right.
noticed. Yes, sir.
3 is 0.28 per unit. So in this iteration number 1, which we have started, Q2 is sure. This is Q3. Q3 is calculated and it's determined as 0.28 per unit. So we do have 3 more variables which are to be completed. What are those 3 variables? Delta 2, delta 3, and mod V2 and mod V2. Now let's see how to compute this. See, this is a power variable, whereas these three are voltage variables. And we do have specific technique for determining the voltage variables in Newton-Raphson method. So let's go back to our technique which we have learned in our previous classes. So what is the technique which we do have now? Relying on the Decoupled matrix, where the equation is known powers is in terms of Decoupled matrix with unknown voltage. So how many unknown voltage terms are there? Three unknown voltage terms. First of all, I will write the angles, two angles, and one magnitude. And here, how many known powers are there? See, 1, 2, 3. Three known powers are there. Two active powers and one reactive power. These are the known powers to me. These are the unknown voltage. So based upon this, this is the Jacobian matrix which we do have. So this is the Jacobian matrix. This is the power matrix. This is the voltage matrix. In order, we already have the values of delta 2, delta 3, and V2. See, we have chosen them as 1 and 0. But we have chosen them, isn't it? We have chosen them as some fake values. Now we do need some real values. So here we will be obtaining the errors in our choosing values, and we need to add to our previous values. Then we will get the true values. So how much to add to our chosen values? This you need to compute. For computing this, what you need? You do need all these remaining things. Once you get all these 12 variables, 3 plus 9, 12 variables, then you can compute these 3 variables and you can add them to your initial values to get your safest values for conversion. Now we will see how to compute these remaining 12 variables now. The first one is this set. This set is called as a power matrix set, where we do need delta P2, delta P3, and delta Q2. So first of all, let me go with the delta P2, which is P2 given minus P2 calculated. P2 is already given for you as 0.5, minus the calculated value. Calculated, how you do have the equation again? Sigma j is equal to 1 to m Vi, Vj, Yij cos theta ij plus delta j minus delta. This was the formula. This is the formula for us, universal formula for active power calculation. Now, with the help of this formula, we calculate what is P2. Now, you see, first of all, let me place J is equal to 1, I is already equal to 2. What I am getting V2, V1. Delta 2 minus delta 2 is 0. Not considering it. So what is the value of P2 calculated? Can somebody do the calculation? V2, V1 and V3. You know these things. 1.04, 1 and 1.0. Y12, Y22 and Y23. These are the values. Can somebody calculate it and say to me what is P2 calculated? Huh? What is the value? Yes. Is everybody doing the problem? Can I know how many of you are doing the problem? Just please raise your hands so that I can go forward. 1, 2, 3. So have you got the answer to this one? What is the value of P2 calculated? Anybody? Anybody in the class? Can anybody write? Shall I expand this one at least for you? V2 is 1, V1 is 1.04. I hope so. I have calculated.
So minus 0.24.
Yeah, 24. Okay, fine. Very good. So this is P2 calculated. So what is P2 calculated? I'll write it in blue ink there. So this is minus 0.24. This is minus 0.24. So in a similar way, let us calculate first of all, before going to subtracting and all these things, let us calculate all this P2, P3 and Q3. Somebody has calculated for me P2. Now let us calculate P3 also. What is P3 guys? Sigma J is equal to 1 to N. The same formula repeats again. So it is mod V3 mod V1 right. This is the formula. So can somebody expand it and say to me V3 is 1.04. And somebody is naming this value. I have expanded it on the board. Can somebody make the calculation and say to me?
Zero 0.12, sir.
Okay. Any other answers, guys? Any other answers? So shall I go with this one? Is it positive or negative?
0.12.
Is it positive?
Yes, sir.
So I'm writing down here minus 0, sorry, plus 0.12. And for the last value now, which I'm going for, is about the other last known power for me, and it is Q2. So let's get back to our Q2. Here we'll get sign, here we'll get minus. I'm expanding it. Can somebody the last value for today?
minus 0.9.
Value. So it is going to be minus 0.9.
7.
So this value is going to be minus 0.9. So these are the powers which I have calculated so far. Now let's get back to our problem. So this is our problem which we need to solve. And here I am slowly eliminating step by step which are the values which are known to me. Delta P2 is given as 0.5, but I have got it as 0.24. So what is the change given minus calculated? 0.5 minus of minus 0.24. 0.5 minus of minus 0.24. Isn't it? So its value is somewhere around 0.74. P3 is given as minus 1.5, but I have obtained as 0.12. So the difference is minus 1.60. And next one is Q2, which is given as 1.0, but I have obtained as minus 0.9. The difference is plus 1.9. So these are the values which I have obtained so far. Isn't it? So these are the values which we have obtained so far. We have obtained three values in the power matrix: 0.74, minus 1.62, and 1 point. Now we need to determine these values. 9 values we are supposed to determine. Don't get tired, you will get the values very easily. See, I have subdivided this one into 4 submatrices: J1, J2, J3, and J4. In J1, how many elements you are requiring now? You will require 4 elements. These two are of one kind, 3 with respect to 3, 2 with respect to 2. And there is another set which is 2 with respect to 3, 3 with respect to 2. We have calculated, we have determined the expression for these elements along. If anybody remembers these things, we do have a formula, dou pi by dou delta I, which was equal to, what was the formula for dou pi by dou delta I? Everybody remember?
Minus qi minus vi square yii sin theta ii.
Minus qi minus vi square yii sin theta ii. This was the formula. Very good. So now let me see if I is equal to 2, this will become minus q2 minus v2 square y22 sin theta 2. So q2 value, we do choose the values which we are actually calculating. Don't go with the standard values. We will stick to our blue values, which we have computed now, which are fresh as of now. So Q2, which is so far fresh, is minus 0.9, which we have obtained in the leads. V2 square, V2 we have already chosen as 1. Y22 is 24.23 and sin theta 22 it is sin minus 76. Yeah. So this is the value minus 0.9 Q2 which we have calculated recently. V2 is 1, Y22 24.23, sin theta 22 is minus 7. Can somebody get me the value now? Guys, can somebody? Is anybody doing the problem, guys?
$24.41.
What the value? What is the value?
24.41.
24.4. Very good, sir. Let me use one more value. T3 with respect to delta 3 is minus Q3 minus V3 square Y33 and sin theta 3. Can somebody get me this value? Q3 is, I think we have calculated Q3, right? It was 2.284 minus V3 is 1.04 whole square. Y33 is 24.23 again. Sin minus 7. Can somebody get me this value also? Come on, guys, faster. Come on, guys, minus 0.284 minus 1.04 whole square 24.23 sines minus 76. What is the value?
$25.14.
25 point. Is it positive or negative?
14. Positive, sir.
25.14. So I have got two values now. These are, I'm writing down here. These are 24.41 and this is 25.14. I have got two values now. So now I will go with the remaining two values. Madam is going to help me. Madam, are you there? Getting the calculations. These are I with respect to J. What is the formula? K with respect to
Minus VI VJ YIJ sin theta.
Is it sin?
Yes, sir.
Is this minus sure?
Yes, sir.
So 2 with respect to 3. This is minus V2, V3, Y23 sin of theta to 3 plus delta 3 minus delta 2. And the answer is V2 is 1, V3 is 1.04, Y23 is 12.13, sin the rest of all are 0, 104. Yes, ma'am. I'm waiting for your answer. before I write on the next one. Literally speaking, both are the same.
12.24.
It is 12.24.
24.
Minus or plus?
Plus.
I think there is an outside minus, isn't it?
Yes, sir. Minus.
The answer is minus 12.24.
24.
So since both are the same, I'm going to write the same value. 12.2 minus 12.2. Yeah. Thank you, ma'am. Now let's get back to J2. J2 is about second matrix. Yeah. This is P2 with respect to V2 and P3 with respect to V2. These are the two known powers, P2 and P3, known active power, unknown voltage magnitude, V2. So now, can I with respect to I, what is the formula?
Pi plus Vi square Yii cos theta Ii.
So with this, it is going to be P2 plus V2 square Y22 cos theta. So P2 we have calculated as minus 0.24. V2 is 1, Y22 is 24.23 because of minus 76. In somebody this value. Whereas the other one is V3. Come on, can somebody give me this value also? Am I right? I with respect to J.
It's positive, sir.
Am I right?
Yes, sir.
So it is V3, V2, Y23 cos of somebody get me these values, guys. What is this value?
5.62.
This one is 5.62.
Yes, sir.
What about this one? Is 1.04. What is the value, beta?
Minus 3.05.
Minus 3.05. Very good, my lady. And I'm going to rub these two values and present to you 5.62 and minus 3.0. And we will move on to the J3 matrix very fastly. Use me Q2 Q2 with respect to delta 2, Q3 with respect to delta 3. Now, can somebody say me what is the formula? 2 with respect to 2, I with respect to I in J3 matrix.
Pi minus Vi square by II cos theta II.
Very nice, very smart. So here it is going to be P2 minus V2 square, Y22 cos theta 2. And the answer is P2 is minus 0.24 minus V2 square is 1 and Y22 is 24.23 cos of minus 76. Yeah, ma'am. Now the last value, can you give me Q2 with respect to delta 3?
Minus Vi Vj by Ij cos theta Ij.
It's going to be minus V2, V3, Y23 cos theta. And its value is going to be minus 1.04. Y23 is 12.13 cos of. Can somebody say me what are these two values? They are nearing to closing the point.
So first one is minus 6.10
Very good.
and next one is 3.05.
Minus 6.10 and this is minus 3 point.
So positive, sir, 3.05.
So I'm closing in with the last matrix now. The three values are replaced. 3.05. And now I do have only one last element which is ready for me. And it is of J4 matrix. Let's get back to that one. It's J4 with delta Q2 by 2 with respect to 2. 2 with respect to 2. So its value is going to be, ma'am,
Qi minus Vi square by II sin theta II.
so this is going to be Q2 minus V2 square Y22 sin theta. So what is Q2 now? Q2 is minus 0.9 minus 1 square. Y22 is 24.23 sin minus. Can somebody give me the value of this one?
22.61.
That's it. So now you're perfectly good. May I know the number? What's your name?
110, sir.
What's your name?
Bhuvana, sir.
These are the final values which we are gonna have for today. So with the help of our lucky master, Bhuvana, I think we have solved this problem. So now You don't need these things. Isn't it? These are all from J1, this is J2, this is J3, and J4. So now you bring this one to this side. So what will happen to this one? It will become inverse. So I'm writing down here. So these are the values which we are going to get for our that is for today. I hope this is going to be your homework. Get the inverse of this one. And we'll close it tomorrow.